Hi ladies, it's Mr. O'Sullivan. As requested during Zoom today, you want to see a few more examples of elimination performed, so I put together a nice little procedure that looks a little different than in class, and it's right next to each of the problems we're going to be solving. All right? So today we're going to be looking at some systems of equations, so if you want to know what the learning target is, I can solve a systems of equations by using elimination. So systems of equations can actually be solved in the following ways: substitution, elimination, and graphically. We have learned about substitution and elimination. Substitution is used when one of your equations is written in the form y equals or x equals. Has to be written in the form y equals or x equals. Elimination, on the other hand, is used when your x's and y's are lined up. It will typically require a little extra work because you're in 9th grade. You're not in the 8th grade. Graphically, we have not learned yet. That is used when a grid is provided for you. We're going to go over that next week, so don't worry about that just yet. In this video, we are going to focus only on doing elimination. So we went over the steps in class, so I'm not going to read, I will, who cares. Steps for solving systems of equations by elimination. So step 1 is make sure that your equations are written in standard form and then your x's and y's are lined up. So when I say standard form, I want it to look like this: ax plus by equals c. So I want my x, then my y, then my c. If your y comes first, it's not a huge issue. I think none of the examples, the y comes first. So yeah, so typically the x comes first, the y comes next, and your constant comes after the equal. Step 1 says make sure that those equations are written in standard form and that your x's and y's are lined up. If you look, my x's are on top of my x's, my y's are on top of y's, equal on top of equals, and number on top of number. Step 2, choose a variable to eliminate. You may have to multiply one or both equations by a constant so that the variable you wish to eliminate has the opposite coefficient. Remember, you want opposite coefficients, so one must be positive and one must be negative. Here's my one reminder. Whenever you don't see something in front of a variable, please put a 1. So here I'll put a 1y, and here I'll put a negative 1x, and here I'll put a 1x. So now what I want us to ask ourselves, and what I need you to ask yourself as you do these questions, I really need you to do this, ladies. I need you to say to yourself, what goes with my x? My negative 1 and my 1. I like that. What goes with my y? Positive 1, positive 2. Not as much of a fan because they are not the same number. We don't look at these numbers. We don't really care about these. But if I look, negative 1 and 1 are the exact same thing, and they're opposite coefficients. So what's nice about this problem is I can eliminate my x's just by adding. So let's do that. I'm going to do negative 1 plus 1, which will give me 0, so I can actually cross these out. And then I do 1 plus 2, which is 3y. 1 plus 5, 6. This now becomes a one-step equation. So step 3 says we added our equations, so one of our variables is eliminated, and now we're going to solve for that remaining variable. So we're going to solve for y. The only way to get rid of that 3 is to divide both sides by 3. So when I divide both sides by 3, I get y is equal to 2. But here's the issue. I'm not done. Step 5 says substitute your answer from step 4 into any of the equations and solve for the other variable. And one of the things I'm adding, choose the easier equation. Fewer negatives, more positives. So the equation I'm going to choose to substitute y into to solve for x is my second equation, that 1x plus 2y equals 5. So I'm going to write down that equation. So 1x plus 2y equals 5. Everywhere I see a y, I'm going to substitute a 2. So I have 1x plus 2 times 2 equals 5. I have to ask myself what 2 times 2 is. Well, 2 times 2 is 4, so I have 1x plus 4 equals 5. And I have to ask myself, how do I get rid of that 4? I'm going to subtract 4 from both sides. So I get x is equal to 1. So my final answer is 1, 2. And you're done with the problem. That is a nice level 1 question where they already give it to you and you just have to go ahead and eliminate. So that's a nice level 1 question. Let's go on to a level 2 question. Level 2. We see that our equation, x's and y's, are lined up. Step 1 says make sure those equations are written in standard form and your x's and y's are lined up. Let's just double check one more time. 15 and 10x, 3y and negative 7y, equal, number. Perfect. Step 2, choose a variable to eliminate. You may have to multiply one or both equations by a constant so that variable you wish to eliminate has opposite coefficients. So remember, you want opposite coefficients, so one must be positive and one must be negative. Ladies, I want you to work smarter, not harder. So if I look, my x's are both positive. That means if I want to eliminate an x, I'm going to have to multiply one of my equations by a negative coefficient. So now if I look at my y's, I have a positive 3 and a negative 7. This means that it will be easier to eliminate my y term, or my y variable. So here's what we do. I have a 3 here, so I'm going to multiply my second equation by a 3. I have a 7 here, so I'm going to multiply this equation by 7. When we figure out what we have to multiply by, that's what we distribute. So I'm going to distribute 7 to 15, 7 to 3, and 7 to 27. I take out my calculator and I do 7 times 15. 7 times 15 is 105. So I get 105x. 7 times 3y is 21y. And 7 times 27 is going to be 189. Now I distribute my 3 to each term on the inside of my parentheses. So I do 3 times 10x, 3 times negative 7y, and 3 times negative 18. 3 times 10x is 30x. 3 times negative 7y is minus 21y. And here's why I didn't have to multiply by a negative 3 or a negative 7. If you look, I've got a positive 21y and a negative 21y. I love that information. Now I'm going to do 3 times negative 18, which is negative 54. I'm now going to use elimination to eliminate my y variables. So what I do is I cross them out because I know those eliminate. 21 plus a negative 21 is 0. Now I do 105x plus 30x, which will give me 135x. And that's equal to 189 plus a negative 54, which is 135. Now to get x by itself, I divide both sides by 135. And I get x is equal to 1. Don't say 0, say 1. So now that I added equations, my variable was eliminated. So I'm going to make this a little bigger now. And I solved for x. Step 4 says I got to solve for my remaining variables. So what we're going to do now is we're not going to use these equations we just created. We're going to go back to the original problem and use one of those equations. So we now need to ask ourselves, which equation do we want to substitute into? Do we want to substitute into equation number 1 or equation number 2? Personally, I would use equation number 1 because it's all positive. So what I'm going to do is rewrite that equation. I'm going to write 15x plus 3y equals 27. And I'm going to use this equation to solve for y. So everywhere I see an x, I'm going to plug in a 1. So I have 15 times 1 plus 3y equals 27. 15 times 1 is 15, so I have 15 plus 3y equals 27. I want to isolate y and solve for y, so I'm going to subtract a 15 from both sides of my equation. And I get 3y is equal to 12. And now to get rid of my 3, I'm going to divide both sides of my equation by 3. So I get y is equal to 4 as my final answer. So now that I solved for y, I can write my final answer as an ordered pair. So I can write this as the ordered pair 1, 4. And then you're done. So that's a level 2 question. The reason why I'm calling this a level 2 question is because if you look, what is it called? If you look, I have a positive and a negative. That's why I call this a level 2, because then you don't have to distribute by a negative. Let's go into a level 3 example, where if you look, I have both positive, so I'm going to have to distribute a negative eventually. So let's just go through the procedure. Step 1, make sure those equations are written in standard form. X's and Y's are lined up. If I look, X's are lined up, Y's are lined up, equals are lined up, and numbers are lined up. That's beautiful. Step 2, choose a variable to eliminate. You may have to do a little extra work by multiplying one of your equations by a constant so that the variable you wish to eliminate has opposite coefficients. Remember, you want opposite coefficients. So one of these must be positive and one of these must be negative. So I'm just going to ask you, what do you want to eliminate? You can do whichever one you want. But remember, everything is positive in this part of my equation because this is all I'm really looking at. So I'm going to eliminate my x's. So if I look at my coefficients, I have a 2 and I have a 3. What we're going to do is we're going to multiply both equations by the opposite coefficient. So I have a 3 right here. I'm going to multiply this equation by 3. I have a 2 right here, so I'm going to multiply this equation by 2. But here's the issue. If I multiply this part by 3, I get 6x. If I multiply this term by 2, I get 6x, which means that these equations would not eliminate my x. So I'm going to have to make one of my distributors a negative. What I'm going to do is make my 2 a negative. You can make your 3 negative, it doesn't matter, you'll still get the same answer. So the first thing I'm going to do is distribute a 3 to each term. I do 3 times 2x, which is 6x. I do 3 times 4y, which is 12y. And then I do 3 times negative 4, which is negative 12. Now I'm going to distribute my negative 2 to 3x, negative 2 to 5y, and negative 2 to negative 3. Negative 2 times 3x is negative 6x. And if you look, that's nice because 6 and a minus 6 will eliminate with each other. Negative 2 times 5y is a minus 10y. And then negative 2 times negative 3 is a positive 6. If you look, these will eliminate, which is great. So I'm going to take out my black pen and cross them out because I know they'll eliminate with each other. 6x plus a negative 6x is 0x. We don't write ox, so we're just going to write nothing. I now do 12y minus 10 plus a negative 10y, which is 2y. And then negative 12 plus 6 is negative 6. What I'm now going to do is divide both of my equations by a 2 and get y is equal to negative 3. And that's your final answer for solving for y. Now what we're going to do is we're going to choose one of our original equations and solve for our other variable. You can choose whichever one. They're both actually pretty straightforward because they're both all positive when you have to distribute. I'm just going to use the first equation where it's 2x plus 4y equals negative 4. And everywhere I see a y, I'm going to substitute a negative 3. So I have 2x plus 4 times negative 3 equals negative 4. I have to ask myself what 4 times negative 3 is. Well, I have 2x. 4 times negative 3 is a minus 12. And that's equal to negative 4. Now what I'm going to do is I'm going to add 12 to both sides of my equation so I can get 2x by itself. And I get 2x equals negative 4 plus 12 is a positive 8. Now what I'm going to do, divide both sides of my equation by 2 and get x is equal to 4. And now I solved for both variables. So my final answer would be 4, negative 3. That's your final answer. And remember, it always goes x, comma, y. If you have any questions, please email myself or Miss Townsend. Make sure you use this to assist you with your elimination delta math assignment, which is going to be taking place tomorrow. And remember, we're going to have a short quiz on Monday or Tuesday on solving a systems of equation by substitution and elimination. Have a great day, ladies, and stay safe.